Hi dears, welcome to Brilliant Qatar JEE Mantra Series Chemistry Recap Test 8. So this is the last series, last recap video. So we discussed many concepts from the many chapters. Here we are going to discuss in this recap. We are mainly focus what? Two topic. That's a very important topic. Actually, that's the basics of all topics. That's actually organic chemistry, some basic principles. Okay, some basic principles and technique. That is general organic chemistry and hydrocarbons. Ready? So in first chapter GOC, general organic chemistry. Mainly we have to learn IUPAC nomenclature. Okay, then isomerism, then reaction mechanism. Each portions are important, and that is whenever we are elaborating, a lot of concepts are there. If you know the reaction mechanism, then only you can apply that reaction mechanism ideas in the grade 12 chapters like alcohol, phenol, ethers, haloalkane, haloarenes, aldehyde, ketone, carboxylic acid, amines, even in hydrocarbon. Correct? Yeah. So the next purification and characterization of organic compounds. That are the four important topics you have to focus mainly. In that itself, first of all, we are looking about IUPAC nomenclature. You learned many ideas about the nomenclature, IUPAC nomenclature. In that IUPAC nomenclature, first, whenever we are writing that prefix, we have to write first prefix. Prefix means always that represent the branch, and then word root. Word root represent the number of carbon atom. It is 1 meth, 2 eth, that idea you know. Okay, I'm not going to waste your time. Okay, see, whenever primary suffix means that represent saturation or unsaturation. Okay, saturation of carbon-carbon bond. If it is double bonded means alkene. If it is all are single bond means ANE. Double bond means ENE. And triple bond means what? YNE. And secondary suffix represent what? Your functional group. Functional group. Okay, functional group. With using these ideas, you must have to remember, you must have to practice a lot of questions. Okay, IUPAC nomenclature that you learned already. Okay, so whenever you are choosing the functional group and the branch, for branch only one rule. Whenever you are naming for branch only one rule, alphabetical order. The one which comes alphabetically first will be writing first. Okay, yeah, will be giving name number first. Okay, and in the case of secondary suffix. In the case of functional group comes in, functional group have high priority. They should have to get the least number, minimum number. Ready? Yeah. So that functional group priority order I am giving here. The highest priority for what? Carboxylic acid, then SO3H, then COOR, then amide, then cyanide, then CHO-aldehyde, then ketone, then OH, then amine, then carbon double bond, then only carbon triple bond is coming. The nitro group, halo group always come as what? Prefix. Always come as alkoxy group. Either group also always come as what? Prefix. That idea you have to keep it in mind. You have to practice a lot of question. Okay, a lot of question from these areas. Okay, yeah. Next, second idea, once we are coming to the isomerism. Isomerism is mainly two types, structural isomerism as well as stereoisomerism. In structural isomerism, they are having same molecular formula, but their structure is different. That may be either because of chain may be different, parent chain may be different, or else position isomerism, position may be different, or else functional group isomerism. Okay, functional group isomerism, their functional groups are different, but they are having same molecular formula. Example, we learned ether alcohol, correct? Yeah, carboxylic acid and acid anhydride, carboxylic acid and ester you learned. Then similarly, one more you learned from here what? Functional group in the case of aldehyde and ketone you learned, correct? Yeah. Then metamerism. Metamerism means functional group will be there. Either side of the functional group, the number of carbon atom will be different. Secondary amine it is possible, as well as either it is possible. That idea you learned. Ready? Then tautomerism. That's actually purely desmotropism. That is purely in liquid state because of the movement of delocalization of hydrogen atom from one polyvalent atom to another polyvalent atom. That related a lot of questions we already did in the previous videos and all. Okay, yeah. Next, stereoisomerism. They are having same molecular formula but different stereo aspects. That means what? Different spatial arrangement. That it may be two type, conformational as well as configurational. Configurational again two type, geometrical and optical. Again, we can look about what? Conformational isomerism. Conformational isomerism means interconvertible, non-resolvable. In room temperature itself, that is interconvertible because of carbon-carbon sigma bond, that rotation only, conformational isomerism. Configurational means they are non-interconvertible. They are non-interconvertible, but they can be what? Resolvable. They are resolvable. Okay. This in configuration are resolvable. And this configuration again divided into two, geometrical and optical. Geometrical means that geometry is different. Optical means optical activity is different. Again, once we are looking about the conformation of ethane, you will infinity, whenever you are rotating that carbon sigma bond, infinity conformers or rotamers are possible. Out of the two are important, staggered and eclipsed. You know how to draw in Newman projection, how to draw in Soho's projection that you learned. In that, staggered is more stable than eclipsed. That also you remember. And in the case of butane, anti-staggered is more stable than gauche, than eclipsed, than fully eclipsed. That idea you have to go through it. Okay, you have to go through the notes. Okay, clear. Next, again, geometrical isomerism. That related number of geometrical isomerism, sometimes they usually used to ask. That's a question. So here in structure, okay, in structure, this mainly for what? Alkenes they are showing. Whenever they are in a plane, same plane, they will show geometrical isomerism. Whenever they are in different plane, they will show what? Optical isomerism. In structure, if the terminal groups are non-similar, not similar, then number of isomers is equal to 2 raised to n. Okay, where n equal to number of double bond. For example, they given CH3, CH double bond, CH single bond, CH double bond, CH single bond, CH double bond, CH Br. Here you see, here the terminal group is Br, here the terminal group is CH3. Both are different. So how many geometrical isomerism are possible? Simply you count the number of double bonds. 1, 2, 3. 3 double bonds are there. Then the number of geometrical isomers is 2 raised to 3, 8. Clear? Yeah. We can go to the next idea. In structure, if the terminal groups are similar, if it is similar, CH3, CH, double bond CH, single bond CH, double bond CH, single bond CH3, both are similar. See, this one are similar. Then what you will do? You will count the number of carbon atom, number of double bond, not carbon atom, double bond. Here 1, here 1. So N equal to 2. Number of double bond equal to 2. Number of double bond equal to 2 means that is what? That's a even number. If it is even number means the number of isomers is equal to the formula 2 raised to n minus 1, 2 raised to n minus 1 plus 2 raised to p minus 1. N is double bond. So 2 raised to 2 minus 1 plus 2 raised to p minus 1. P is what? P equal to n by 2 when even number. So n by 2 means that is 1. So 1 minus 1. So that is actually 2 raised to 0. So 2 raised to 1 plus 2 raised to 0. That means 2 plus 1. 3 will be coming like that. If it is even number means P we have to take it as n plus 1 by 2. Idea okay? Yeah. We can go to the next idea related to optical isomerism. That related a lot of ideas you learned in where also. In haloalkanes also we discussed already. So the condition for optical isomerism, optical activity is what? In the compound having only one chiral center, that compound is optically active. Chiral center means around carbon all the 4 groups are different. That is what is called a chiral center. You remember? Yeah. If a compound having more than one chiral center not sufficient for optical activity, there should be, in that case, whole molecule must be unsymmetrical because meso compounds also possible. Mesomers. In the case of mesomers, in the same molecule, because of internal compensation, their optical activity is 0. That also you learned, okay. You have to focus that one. Then again, enantiomers, diastereomers. Enantiomers means they are optically active, non-superimposable mirror images. One is D means another one will be L. And here diastereomers means they are non-superimposable, non-mirror images which may or may not be what? Optically active. Okay. Then again, identical physical and chemical properties for enantiomers, but in the case of diastereomers, differ in physical and chemical properties. And in the case of enantiomers, cannot separate enantiomers by physical methods. We cannot separate them. But diastereomers, their physical properties are different. So we can separate them by using what? Physical methods. That idea you have to keep it in mind. Again, the reaction mechanism. In reaction mechanism idea, you know that is very important. Organic molecule, they cannot directly give the product. First, they will react with attacking reagent. The main our hero, the organic molecule in organic chemistry, the main hero. That carbon is called what? Substrate. That will be attacked by an attacking reagent that will form an intermediate. If the intermediate is stable, then only the further reaction will take place. That will give product as well as byproduct. The intermediates, okay. So whenever we are discussing about that bond breaking in covalent bond, two types of breaking are there. Homolytic fission, heterolytic fission. If the bond is breaking equally, one electron is given to this A, one electron is given to this A. Fissure. That is what is called homolytic fission. In homolytic fission will be taking place at a high temperature, okay, light, in presence of light, UV light, or else non-polar solvent, or else presence of peroxide or oxygen. They will form free radicals always. Free radical always, homolytic fission. What about heterolytic fission? If two different atoms comes means they will undergo heterolytic fission. One atom will, highly electronegative atom will take the entire electron. So another one atom will be forming positive, another atom will be forming negative. Cation as well as anion will be formed. So this will be occur at a low temperature, cold condition, and in presence of what? Polar solvent like acid, base, etc. Clear? Yeah. Next again, whenever you are looking about the reactive intermediates, there are so many reactive intermediates are there. One among them is free radical. In free radical, the carbon that is trivalency neutrally charged. They don't have any charge. Trivalency 1, 2, 3 charges are 3. Trivalency is there. And in the vacant p orbital, one odd electron is there. That is what is free radical. Okay, in the case of free radical, their stability order is this one. You know, the stability order is very important. This is tertiary benzylic is more stable than secondary benzylic, than primary benzylic, than what? Than allylic. Okay, than tertiary, than secondary, than primary. Normal alkyl. Okay, normal alkyl, tertiary alkyl, secondary alkyl, primary alkyl, then methyl, then ethinyl. Okay, ethinyl, then what? Acetynyl. So like that we can tell. Okay, or else it is called vinyl. This is ethinyl free radical. And phenyl free radical is highly unstable. That order you must have to remember. Okay, at least you have to remember this much idea. And from here also you have to remember that benzylic free radicals are more stable. Next again, carbonium ion or carbocation. Okay, carbonium ion or carbocation. Carbonium ion or carbocation means that's actually carbon with a positive charge. That is carbon with a positive charge. Around it, 3 bonds are there. Okay, so that in their stability order, once we are looking, see that in that case, that primary, see here you can see this actually the methyl is less stable, then ethyl, primary, then secondary, then allylic, then only then benzylic will come, primary benzylic, then tertiary butyl. Tertiary butyl is more stable than benzylic because of in the case of this one, resonance. 5 resonance is possible. In this case, 9 hyperconjugation is there. You learned the hyperconjugation actually stabilizes the carbocation. That idea you have to keep in mind. That order is very important. Okay? Yeah, because whenever the carbocation related mechanisms comes means, always they will try to become tertiary carbocation. Okay? Yeah. Next, again, this is actually carbanion. Carbanion means carbon with a negative charge. Around carbon, 3 valencies are there. Then along with one orbital, sp3 hybridization, here one orbital contain one lone pair. So trivalency negatively charged carbon atom. Their stability, once we are looking, that methyl is more stable. Whenever we are looking, that methyl is more stable. Okay, methyl is more stable. Normal methyl carbanion is more stable than tertiary is less stable. Tertiary, secondary, etc. are less stable because whenever you are looking, see the CH3, okay, minus. This actually tertiary. Whenever this tertiary will again provide the electrons to this one, they will pump the electrons to this carbon, their stability will decrease. So they are less stable. But if it is methyl means that is more stable. And in the case of benzylic, as well as primary benzylic, secondary benzylic, allylic, they are again stable because of resonance. That idea also you have to keep it in mind. Okay. Then next again, carbene. Carbene also very important thing. It's a divalently neutral electron deficient carbon atom is called carbene. Okay. Carbenes containing 6 electrons in its valence shell. 4 electrons are bonding electrons. Remaining 2 electrons are unshared non-bonding electrons. That carbenes may be 2 types. First one is singlet carbene. Second one may be triplet carbene because of their spin nature. Okay. Yeah, spin multiplicity. That we can find out by using 2s plus 1. Simple idea. Singlet carbene means that carbene is in sp2 hybridized carbon. Okay, that carbon is in sp2 hybridized carbon. Two bonding molecular orbital are there. 2 bond pairs are there. And one sp2 hybridized orbital is this one. Okay, and here one p orbital also there. Because sp2 means one p is vacant. And this sp2 contain what? Paired electron. paired electron, but they are not non-bonding. They are not participated in bonding. That is actually lone pair. So, but because both are their spin, once you are calculating, this spin will be cancelled by this spin. So 2 into 0 plus 1. I mean 2 into this will be plus 1 by 2. Another one will be minus 1 by 2. Once you are adding, you will get 1. That's why it is called a singlet carbene. Singlet carbene. And it is diamagnetic because its spin will be cancelled, its spin. And if it is triplet carbene, once you are looking triplet carbene, that's in sp hybridization. That means what is there? 2 bond pairs are there. 2 sp2 hybridized orbitals are there. They are in linearly arranged. 2 p orbitals are vacant. One is this p orbital, another is another p orbital. If they are using px, then py, pz are remaining. Okay, or if they are using pz, px, py are remaining. In each p orbital contain 1 electron. So what's the spin? What's the net spin? Spin multiplicity 2 into this plus 1 by 2 plus this plus 1 by 2 plus 1. So that is 2 plus 1, that is 3. That's why it is called a triplet carbene. That is paramagnetic because unpaired, not paired. Idea clear? Yeah. Next again, once we are looking about electrophiles, okay, electrophiles are electron deficient species. These all ideas we already learned. Anyhow, we are telling again, okay, electron deficient molecule, they have a high tendency to gain electrons. So neutral molecule like B3, BCl3, AlCl3, BeCl2, FeCl3, SO3, etc. are electrophiles. They will be also called what? They will be also called what? Lewis acid. They have a tendency to gain electron. Yeah. Or else charged means all positively charged ions. All positively charged ions, they can act as what? Electrophiles. Clear? Yeah. Next again, once we are looking about nucleophiles. What about nucleophiles? They are electron-rich species. They are seeking nucleus. What's the charge of nucleus? Nucleus is positive charge. So that means there may be either charged nucleophiles, means negatively charged species always seek positive charge, like F minus, Cl minus, Br minus. That kind of reactions you have to learn in were haloalkane substitution nucleophilic reactions. And once it is neutral nucleophile, means that should contain what? Lone pair, extra electron rich molecule. That electron richness will be available as what? Lone pairs. NH3 contain 1 lone pair, H2 contain 2 lone pair. Among them 1 lone pair they can donate. They are actually ligands. You learned that idea. Yeah. Next again, once we are going to look about their effects. First effect is inductive effect. Inductive effect is a permanent displacement of sigma electrons. Permanent displacement of sigma electron. Whenever your carbon sigma bond is connected with a highly electronegative atom or highly electropositive atom. If it is electronegative, means that will withdraw all the electron towards it. Through that, all the sigma electron towards it. So they will get a partial negative charge, here partial positive charge. Because of that, it will try to withdraw the electron towards it. It will get a partial positive. So it will be partial positive. Partial positive will get. This is what is called inductive effect. Delocalization of sigma electron. Sigma electron is initially between that carbon bond or else carbon halogen bond. They will simply shift, simply delocalize. That is what is called what? Inductive effect. The group which is taking electron, they are called minus I effect showing group. The group which are donating electron, they are called plus I effect showing group. In the case of minus I effect order, that NO2 group, electronegative group, this is nitrogen is there, carbon is there, S is there. So whenever that electronegative group is there, means they have a tendency to withdraw. Their order is this one. You have to remember at least NO2, Cn, CHO, CO, F, Cl, Br. Okay, I. That order you have to remember. Clear? Yeah. They have a tendency to withdraw the electron, then they will get what? Partial negative charge. And similarly, plus I effect means electron donating tendency, electron pumping tendency. That is for tertiary, then secondary, then primary, then methyl will come. And whenever the number of carbon atom increases, if it is methyl is there, ethyl is there, then propyl is there, okay, then whenever the number of carbon atom increases, the electron pumping tendency, plus I effect will increase. That idea also you have to keep it in mind. Clear, dears? Yeah. Next again, resonance effect. Resonance effect means the polarity produced in the molecule by the interaction of two pi bonds or between a pi bond and lone pair. Because of that electron, complete displacement of that pi electrons. Okay, because of that polarity is developing. That may be two types, either plus R effect or minus R effect. Plus R effect is showing groups. Plus R effect means they are actually ortho-para-directive group. Ortho-para-directive group, or else they are called a activating group. Whenever these kind of groups are attaching with the benzene ring, they will always activate they will always make the benzene ring electron rich at ortho-para position. That's why they are called ortho-para-directive. So whenever an electrophile comes, means it can attack at ortho-para position. How we will identify which is a plus R effect showing group? Because they have a tendency to donate electron pairs. So they should contain electron pairs. So lone pair containing group, okay, lone pair containing group can act as what? Lone pair containing group can show what? Plus R effect. And what about minus R effect showing group? Minus R effect means they will withdraw, they will take the electron away from the conjugated system. Away from the conjugated system, they will take it out. That time, the conjugated system will get a positive charge. That become electron deficient. That means they will become deactivated. So that groups are called meta-directive or else deactivating group. If there is a deactivating group, how we can identify deactivating group? By checking that compound, that group should contain a double bond that should be attached with the conjugated system. Here you can see double bond OH. If you are connecting this one with the benzene ring, here double bonded carbon is there, that is connecting with the benzene ring. So here you can see that is attached, that's what kind of group? That's a minus R effect showing group. Idea clear, dears? Yes or no? Yeah. Next, again, electromeric effect. Electromeric effect means complete transference of a shared pair of pi electrons to one of the atoms joined by a multiple bond in presence of attacking reagent. Suppose you are having carbon-carbon double bond, carbon-carbon double bond. If an attacking reagent comes, electrophile or nucleophile, suppose if electrophile is coming, see, electrophile is coming. Okay, electrophile is coming, its charge is positive. This is completely shifting to here. That pi electron is completely shifting to any one of the carbon atoms. Suppose it is shifting to here. So now you can see this become carbon. Okay, around this carbon, here one bond, here one bond, here one bond, here one bond. This become negative and this become positive. This electrophile will come and attach to the carbon in which electron is getting. So here electrophile will attach. So the same carbon in which that attacking reagent is attaching, then that is called plus C effect. That effect is called plus electromeric effect. If you are taking, see, listen to me, if you are taking carbon-carbon double bond, okay, to that if you are treating with the nucleophile, this is a carbon-carbon double bond, okay, so this will be shifting to here. So I can write like what? Carbon, 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 this will become negative, this will become positive. Towards where this nucleophile will go and attach. Here this nucleophile will go and attach. Here this nucleophile will go and the charge will disappear. So now this carbon is getting electron, but attacking reagent comes and attach here. Meaning what? This is what is called minus E effect. Minus E effect. So whenever the attacking reagent, this nucleophile is leaving, it will go back. So it is what? It is a temporary effect. It's a temporary effect. So here what is actually happening? The pi electrons are shifting from any of the joined atom by a multiple bonds. Okay? Yeah. That's the idea, electromeric effect. Again, hyperconjugation. Hyperconjugation means sigma electrons of CH bond of alkyl group enter into partial conjugation with the unsaturated system or with the unshared p orbital. By using this hyperconjugation only, we are explaining what? We are explaining the stability of alkene, stability of carbocation, all idea. That idea you must have to remember, guys. You must have to remember, okay. That's all about the chapter what? That's all about the chapter about the chapter general organic chemistry. You have to focus a lot of questions you have to do. Already we did a lot of videos related to that. You have to go and check it. You have to watch it, okay. So dears, next we have to focus the chapter hydrocarbons. Here mainly we are learning 4 things: alkanes, alkenes, alkynes, benzene. Their preparation, their physical properties, their chemical properties and uses. Correct? Yeah. So first of all, we can look about, once we are looking about alkanes, in alkanes, first we have to remember about Wood's reaction. You know haloalkanes that react with the 2 sodium in presence of dry ether. What they will give? What they will give? RR. Alkane you will get. That alkane will be having always double the number of carbon atom in the haloalkane. Okay, whenever you are taking a mixed haloalkanes means you will get a mixed alkanes. That idea also you remember, I hope. Yeah. Next again, decarboxylation. Decarboxylation means removal of carbon dioxide. Here we are taking sodium salt of carboxylic acid, R, C, double bond O, ONA, sodium salt of carboxylic acid, that we are treating with the sodium hydroxide and CaO. Okay, and CaO. This is what is called a soda lime. This reagent is called a soda lime. Whenever you are treating with this one, this COONA and NaO, that is Na2CO3 will be eliminated. Na2CO3 will be eliminated, remaining is RH. So that is an alkane. And here CaO is used to keep our NaOH dry, or else answer will be alcohol. So this is what is called decarboxylation. Here one molecule of CO2 is eliminating, that's why it's called removing CO2, that's why it is called what? Decarboxylation. And the next idea is Kolb's electrolysis. Here also we are taking sodium or potassium salt of carboxylic acid and we are conducting what? We are conducting electrolysis. Whenever we are conducting electrolysis, at anode we will get RR and CO2. At anode we will get, alkane and carbon dioxide, we will get KOH and H2. We will get at what? Cathode. That idea also you have to remember, guys. You have to remember. So whenever I am taking CH3, COOK, okay, potassium acetate. Potassium acetate, if I am treating, if I am conducting electrolysis, the products will be like 2 CH3 I have to take, RR. So 2 CH3, that means CH3 single bond CH3. That is ethane I will get. Then this will become carbon dioxide. This potassium in water will give what? Potassium hydroxide and hydrogen they will liberate. This is what is the reaction of what? Kolb's electrolysis. That idea you have to remember. Okay, dears. Next again, whenever we are coming to the chemical properties, a lot of reactions are there. Free radical substitution is there. Pyrolysis is there. Then Then their aromatization is there. Isomerization is there. Out of that, the important one is what? Aromatization. That means normal long chain alkane that contains 6 or more carbon atoms will give this reaction aromatization. When you are treating that one with interstitial metal oxides like chromium oxide, Cr2O3 or else V2O5 or else MO2O3 at 773 Kelvin and 10 to 20 atm, they will undergo aromatization. They will give you benzene. You are taking here 6 carbon. 6 carbon is C6H14 you are taking. 6 carbon containing chain will come to they will be becoming aromatized. They will undergo aromatization. They will become aromatic compound benzene C6H6 by liberating 4 hydrogen. So it is actually a kind of dehydrogenation. Okay, if you are taking 7 carbon means what will happen? 7 carbon if you are taking means 6 carbon will form a cycle, benzene, and 1 carbon will be there as a extra, that is toluene you will get. If you are taking 8 means 6 carbon containing ring, benzene. On that ethyl group will come, ethyl benzene you will get. That's the idea. Clear? Yeah. Next, once we are going to look about the preparation of alkenes. Alkenes we can prepare from alkyne. I am taking alkane. To that I have to add hydrogen. But if I am adding continuously hydrogen means it will go up to alkane. But I have to finish at alkene. I have to stop at alkene means I have to restrict that hydrogen addition. For that I am using palladium, partially deactivated palladized charcoal. That is what is called a Lindlar catalyst. Lindlar catalyst. That Lindlar catalyst. Okay, see, Lindlar catalyst. That is what is called a Lindlar catalyst. Okay, Lindlar catalyst. So here actually you are partially deactivating that palladium by using charcoal mask or else calcium carbonate or else barium sulfate or else quinoline. That all you can utilize to partially deactivate this palladium. That time hydrogen will be added in the same side. That is what is syn addition. Syn addition. So you will get a compound cis-butene. Cis-butene you will get. But if you are using sodium in liquid ammonia, 1 hydrogen will be added here, 1 hydrogen will be added here. So that is what? That is actually trans addition. That is trans addition. Okay, trans addition. So the compound you are getting is trans. You are adding in the opposite side. That is what is called anti-addition. Okay, anti-addition. That is what is called anti-addition. The compound you are getting is trans-butene. Trans-butene. Okay, trans-butene you will get, and this reaction is called a Birch reduction. This reaction is called what? Birch reduction. That idea, please keep it in mind. Okay, yeah. So if you are using Lindlar catalyst, you will get cis product. Okay, same side. And if you are using what? Sodium in liquid ammonia, opposite side, that is Birch reduction. Okay, yeah. We can go to the next idea. Beta elimination. The same idea you learned were beta elimination as the ISOP rule you already learned were haloalkanes. So that will be easy for you from whenever you are taking an haloalkane. Once it treated with alcoholic KOH, the halogen attached carbon, that is alpha, that attached carbon is beta. From beta, 1 hydrogen. From alpha, 1 halogen. They will be eliminated, and in between alpha and beta, a double bond will come. You will get what? An alkene you will get. This is what is called a beta elimination. That related If it's an unsymmetric alkene means we can, unsymmetric haloalkene means what? What we can do? Unsymmetrical haloalkane means what we can do? We can use what? That Zayesov rule also we can use. That idea you have to keep it in mind. Again, we can go to the chemical properties, the addition of hydrogen halide. Okay, addition of hydrogen halide. Whenever you are adding hydrogen halide or unsymmetric reagent to an unsymmetric alkene, you have to follow the Markovnikov rule. Okay, you have to follow the Markovnikov's rule. Markovnikov's rule purely based on the carbocation mechanism. So rearrangement is possible. So the thing is that rich become richer. Okay, rich become richer. In not rearrangement cases, non-rearrangement cases, this hydrogen. Here you can see that carbon-carbon double bond. You can see dears. Here you can see that carbon-carbon double bond. Here this carbon is rich in hydrogen. Towards that, this hydrogen will go. Towards this bromine will go. That's the answer. CH3, CHBr, CH3, 2-bromopropane. That will be the major, and opposite, that is actually the minor. That's purely based on the Markovnikov rule. So you have to focus. That is following through which mechanism? Carbocation mechanism. So which will be the more stable carbocation? Accordingly, the reaction will take place. Okay? Yeah. Next again, anti-Markovnikov addition. That also you have to keep it in mind. Anti-Markovnikov addition or peroxide effect or Karash effect. This for unsymmetric alkene. This is unsymmetric alkene because carbon-carbon double bond here along with carbon 1 hydrogen, here along with carbon 2 hydrogen, unsymmetrical alkene, that only react with HBr. Not for HI, not for HCl, only for HBr. This anti-Markovnikov rule or peroxide effect is only for what? Only for HBr. In presence of peroxide, anti-Markovnikov addition will take place. Opposite to Markovnikov rule, addition will take place. So hydrogen will go along with less number of hydrogen containing carbon. Br will go here. It's only for what? HBr. That idea also you have to keep it in mind. Okay? Okay, Ds. Next again, once we are looking about ozonolysis, if you are having an alkene that you are treating with ozone, that will be forming an ozonide. Once you are treating with zinc and hydrolyzing, it will be giving an aldehyde or ketone. That related question will be there easily. Also we teach you, I taught you during aldehyde ketone. Whenever you want to conduct the ozonolysis for this molecule, what you want to do? You just break this one, put one O here, put one O here. That's all. The double bond you break, put O here, put O here. That will be the answer. Okay? Yeah. Next, alkanes. In the case of alkanes, mainly one thing you have to remember, alkanes have acidic character, especially primary alkane. I mean, one alkane. That alkane, triple bond comes on first carbon. They are highly acidic in nature because that carbon is an sp hybridized carbon. See, sp hybridized carbon means you can see that connected with hydrogen. Sp hybridized carbon means it has 50% S character. S character increases, electronegativity increases. Electronegativity increases means it will take that electron towards it. Automatically this hydrogen can escape as H+. So it will be acidic in nature. That related idea you have to keep it in mind. Compared to alkene, alkynes are acidic, but not as that much as that of alcohol. Okay, they are less acidic than alcohol. Okay, yeah. Next again, cyclic polymerization of alkyne. If you are taking acetylene, this is acetylene. If you are taking and if you are treating that one with a red hot iron tube, it will give you benzene because of what? High temperature free radical homolytic fission reaction. They will form what? This benzene. And if I am taking propyne, see CH3, C triple bond CH 3 times if I am taking, and if I am treating that one with red hot iron tube, your product will be 1, 3, 5. Okay, here 1, 3, okay, and 5. 1, 3, 5, 1, 3, 5, trimethyl benzene. This is what is called a mesitylene. You will get that idea. You have to keep it in mind, guys. Then next again, then finally you have to remember about what is aromatic, what is anti-aromatic, what is non-aromatic. Okay, that related questions will be there. Aromatic means it should be cyclic and that ring must be planar. That means all should be sp2 hybridized and continuous conjugation, alternative double bond and single bond. There should be a possibility of what? Electron displacement. Okay, and obey Huckel's rule. That means 4n plus 2 pi electron, n value should be 0, 1, 2, 3. That means multiple of 4 plus 2. That many pi electrons should be there. Anti-aromatic means they are cyclic, planar, continuous conjugation. Only the difference is they contain obey Huckel's rule for anti-aromaticity, that is 4 and pi electron. Multiple of 4 pi electron, 4, 8, like that it will come. Here it will be multiple of 4 plus 2. And non-aromatic is there, that will be cyclic, planar or non-planar. There may be non-conjugation, there should not be conjugation, and does not follow Huckel's rule. Both the Huckel's rule, they won't follow. Okay, they are actually what? Non-aromatic. Always you have to remember, aromatic is more stable. Aromatic is more stable than what? Non-aromatic. Non-aromatic than what? Anti-aromatic. Than anti-aromatic. That idea you have to keep it in mind. Let me explain with one example. Easy guys. Easy. See, here once you are looking, these 3 compounds, okay. These 3 species, you just check it. Here one, negative. Here you can see the another one, here positive charge, and here you can see one more thing I will take, this one. So first I am looking about this one, you can see this actually cyclic, all are sp2, 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 carbon in a ring with a positive or negative charge is sp2. So that's all are planar. Conjugation. What is conjugation? This can shift to here, this can shift to here. So it will give the resonance structure like this. Here double bond, here negative, here double bond. Again it will shift to here, it will shift to here. You will get another resonance structure like this. See, here double bond will come, here double bond will come, here negative charge. How many pi electrons are there? How many electrons are participating in delocalization? 2, 2, 2. So total 6 pi electrons are there. 6 pi electrons means multiple of 4 plus 2. That means 4 plus 2, 6. So that is aromatic. This species is aromatic. This species is aromatic. What about this one? Once you are looking cyclic. Okay, planar, all are sp2, 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 sp2. And conjugation, yes, conjugation is there. This bond can shift to here, bond to bond shifting. So you can see here double bond, here plus charge. This bond can shift here. So that time also you can see here double bond, here plus charge. So how many pi electron? 2, 2, 4 pi electron, multiple of 4. That is what? Anti-aromatic. They are anti-aromatic. What about this one? This one cyclic, but not planar. This is sp2, this is sp2, this is sp2, this is sp2, this is sp3. Non-planar. Non-planar means non-aromatic. This way we can solve the questions. Clear? Yeah. Next again, the last idea, electrophilic substitution in benzene. That electrophile for nitration, NO2 plus is the electrophile. That you can substitute. For that you have to take the reagent, concentrated HNO3 plus concentrated H2SO4 you have to take. That time HNO3 will act as a base. From that OH minus will go. Then remaining will be NO2 plus. That will be go and substituted on benzene instead of hydrogen. That is nitration. Halogenation means you can take any halogen in presence of what? FeCl3 or else AlCl3 you can take halogen. X plus will be generated. X plus will be generated, that's an electrophile, that is halogenation. What about sulfonation? Here the electrophile is SO3. SO3 structure is like this. You can see guys, S, here O, here S plus O minus. This S portion, that the center portion is electrophile. So SO3 group will be substituted instead of hydrogen. Okay, that is sulfonation. For that you have to take fuming sulfuric acid, fuming H2SO4. That is actually H2S2O7. Okay, H2S2O7 you can take means instead of hydrogen that will be substituted. And Friedel-Crafts reaction that we already learned. Friedel-Crafts acylation is there. Friedel-Crafts alkylation is there. Friedel-Crafts alkylation means any haloalkane. Any haloalkane you can take along with anhydrous AlCl3. Anhydrous AlCl3. That will, anhydrous AlCl3 is called Friedel-Crafts reagent. If it is acylation means you have to take acetyl chloride. CH3COCl in presence of anhydrous AlCl3. That will give you CH3CO plus. This will give you CH3 plus. That reaction you already learned. A lot of reaction, a lot of electrophilic substitution you already learned in haloalkane, haloarenes you learned, as well as alcohol, phenol you learned, as well as you learned for anisole case you learned, benzaldehyde case you learned, aniline case you learned. So that idea you already learned. It's higher version you already learned. This is actually the basic ideas. Anyhow, instead of reading the theories, you have to practice. I simply give the recap, the important topic I mentioned. You just go with question and practice a lot of question, guys. That's all about the recap video 8. And after this one, after this recap, we will see with a lot of question, a bunch of questions. Okay, you have the complete full test will be there. So do maximum questions, dears, maximum question. We are going to crack it. Okay. See you in the next video. Thank you so much.